All right, several of you said you had questions about your homework last night. Give me questions about your homework last night. What did we do? Continuity, types of discontinuity, definition of continuous. Yes, we can. All right, so number 5, and so it asked us to find the points of continuity and the points of discontinuity of the function, identify the type of discontinuity. So we have y equals the square root of 2x plus 3, and if you think about a radical function and what this looks like, it's just backed over some. It's going to look about like that. Is that a continuous function or not? Yes. Did I have to pick my pencil up whenever I drew it? No, I started here and I went off. I never had to pick my pencil up. So it's continuous, so there are no points of discontinuity there. Does that make sense? Yes, Miss Van. No, Miss Van. Thank you, Van. Yes. 10? 10, the natural log of x plus 1. What do we know about natural log graphs? This is one of those parent functions that you need to know what it looks like. It's the inverse of what? Okay, no. It's the inverse of E, and E is not, well, E is a what kind of graph? A growth, right? Remember what growth looks like? It looks like that, and this is the inverse, so this is twisted around. Are y'all okay there? Okay, maybe look at your calculator and let's graph it. Straight chillin'. Oh no, don't do another one. Natural log of x, what is it? The plus 1 is just going to be a shift for us here. Remember it now, what the log graphs look like? All right, so my question here is it continuous? It's, okay, so, but y'all put it in parentheses there? Oh, it doesn't matter on Desmos. There is a vertical asymptote at -1. So for the domain of this function, what's the domain of this function? So tell me here. All right, so tell me the domain. -1 to infinity, parenthesis or bracket. It gets a parenthesis, why? Didn't hit -1. For the range, right. But let me ask you this. Is it continuous on its domain? Yes. It's not a bracket. The domain does not include that, so we say that it's continuous on its domain. So in its domain, it does not have any discontinuities. Does that make sense?
Oh, I just had a question on how to format one.
Okay.
Well, on the it said it's a separate at x equals. But I just do like brackets with like A's and stuff.
At what values? Oh, yes, I would definitely do the way you said. Yeah. So I would say that 14 is continuous. This is that funky little, like this. This is 1, 1. This is -1, 0. This is 0, -1, 0, 0. No, you had them all. 1, 2, 2, 0, and 3, 0. And so it says to name the continuous, the values of f that's continuous. I would do it exactly like you did, Lizzie. I would say from -1 to 0, but it doesn't include 0 because it's not continuous at 0. That's a what kind of discontinuity is this? That's a jump. That's a jump. It picks back up at 0 and it goes to 1, but it doesn't include 1 because this is a what? A hole. A hole in the graph. And then I come down here and it's still continuous until I get to 2. Again, what is this? It's another hole. It's not plugged, but that's okay. And we're going to talk today about how to plug those holes. And then from 2 to 3, again, a hole. It's not plugged, but. So those are the intervals on which the function is continuous. What else on your homework? Yes. Number 7. On number 7, I'm going to go with you probably need, oh, this is a non-calculator. Well, what do we know is happening here? The absolute value. And what should be happening here? It should be some type of discontinuity, right? Because x cannot equal 0. If it were a polynomial over a polynomial, we would automatically say that was a vertical asymptote. But because of that other function, that absolute value in the top, this is not something that I would expect you to do without a calculator. How do I close it? What's wrong with it, man? You can't find it? Oh, let me, it says anyone can view. Okay, let me copy it again. Try it now. Get the new link and try it. My maiden name or my middle name? Okay. Let me not put this on a 21. So, and we've kind of been talking about this in pre-cal this week, so it's odd that this one's here. We've been talking about continuity in there, obviously not the level that we're talking about continuity in here, but we've still been talking about continuity nonetheless, and we've talked about continuity of piecewise functions. And to understand continuity of piecewise functions, you have to understand where the breakdown is happening, right? Like, where would I not be continuous? Where are points undefined? So take this first one. Obviously, it's happening where? At 1, right? That's my problem area. That's where this graph is going to have a vertical asymptote or a point of discontinuity. Something's happening at 1. So if I look, that's where my restriction is here. And we're going to do a lot with this today, too. So the question is, yes, when I fill this hole here, or when I fill this spot, am I filling it, in other words, is it continuous? Does it put a point? She's not just going to give me here, right? See if this could make it become continuous, essentially, if we plug that point in. Well, if you think about what this looks like, okay, this is that graph with the crosshair asymptotes, right? But it's just instead of it being the x and the y-axis, it's been shifted which way? Right? Remember those function transformations? All right, so this one is going to look like, to the right one, yes, sir. You don't know how to do piecewise functions? Okay. Graphing them or what they look like or what? Okay, so if this is what I do first, and this is the easiest way to understand them. It's not the most efficient way to graph them, but it's the easiest way to understand them. This is the graph of 1 over x minus 1. Do you agree or disagree? But it says x has got to be less than 1, right? So here's where x is 1. So essentially what I want to do is I want to erase any part of the graph that's not less than 1, because this tells me x has got to be less than 1. So I'm just going to come here and erase this because it tells me x has to be less than 1. Does that make sense? Okay, so no other part of the graph applies because my domain has been restricted. And that's all they're doing is restricting domains. They're cutting it off and telling you only use this piece of the function. Okay, piecewise, right? Here, so this one, when we're in a situation like this, and this is the other way that I teach students to graph it, whichever way is easiest. I call this the eraser method, where you erase the part that doesn't apply. Or you can take the boundary. It doesn't work with this one, but here you can take the boundary and you can plug it in this to find your kind of your starting point, where you're going to begin, where that cutoff is going to happen. So here, 1 squared minus 2 times 1 plus 5. Negative 1 plus 5, which would be 4. So this point is 1, 4. Do you agree? Okay. 1, now remember, this was like an asymptote. I don't know why that line just went there, but it did. And I'm bubbling it in because of this line under. So this is a parabola that opens up, but I'm literally slicing it right here, and I'm only going to include this portion of it. Does that make sense? Because it has to be greater than 1. It has got to be bigger than 1. So maybe I let x be 2 because that's bigger than 1. And I say, okay, well, if I plug that in here, 2 squared minus 2 times 2 plus 5 would give me 5. So it's this piece of the parabola. Now I can visualize what it looks like. This didn't ask me to graph it, I don't think, but in order to kind of understand, I needed to at least think about what that graph looked like. So now, is this continuous? One is, before you answer that, is it a function? Yes, it still passes vertical line test, right? They don't overlap on each other. So now my next question is it continuous? No, I would say no as well. What type of discontinuity do you think? Infinite. I would say an infinite discontinuity. I would say if you also said jump discontinuity, I wouldn't necessarily disagree with you. The only problem is this side is not defined to jump to another one. Is the only reason why. Right. And do you see the difference here in why we say this function is not continuous even on its domain? What's the domain here? Negative infinity to infinity, right? Because look, you can't leave 1 out because it's included here. So now, even on its domain, it's not continuous because, yes, this is a point, but it's also an asymptote here. Remember yesterday y'all were asking me, and it can bound a portion of the graph and not the entire graph. So that asymptote is bounding this part, but it's not bounding that part, if that makes sense.
But let's say, for example, it wasn't, let's say it was x, for the second part, x is greater than 1, what would the domain be? Not greater than or equal to 1, greater than.
Then the domain would leave out 1.
So it would be negative infinity of 1.
And I would say that would force it then. Well, it's still not continuous. Well, it'd be continuous on its domain, because if you left one out of the domain and that's where the discontinuity occurred, does that make sense? Your third or fourth block has to take you.
Oh, no, I had my. I had during third block. Oh. Wait, Kona Ice comes to high school? Who's going to go? No. What if you have 8? No, Kona Ice.
Wait, so I have.
I was planning on you doing it in groups, but I think we'll just talk through this as a big group since we're such a small class anyway. I want you to think about this for just a second. And I want you to tell me, what is the domain without graphing algebraically? What is the domain of f of x?
Infinity to negative
3, pick up negative 3 to 3. Right?
Wait, so what's that little symbol called that connects them?
Oh, wait.
You?
Would that be y? Y is
What? Wait.
It's a radical function, but they're also two parabolas.
so for it to be a whole text, x of negative 3 is going to be.
And that's one of the things we're going to talk about.
Isn't this a radical function?
Okay, but all right, so let's talk. There's a couple of things that's not a radical function. A radical function is a square root, quadratic.
No, when it's divided by something.
Oh, rational. All right, so we're thinking about domain. This is what pre-cal took their test on yesterday. We're thinking about domain. So for domain, I'm looking at what all x can't be, and I'm looking, when I'm in the situation of a rational function or things like that, I'm looking for square roots and fractions, right? Square roots need to be bigger than or equal to 0. Fractions, the bottoms can't be 0, right? And I need to leave out anything that causes those. Okay, so it can't be 3, or, so how do I say that? Give me the domain, though, in interval notation. Does that confuse anyone? We're going to factor it in just a second. Because we're setting the bottom to 0. So x squared can't be 9, which means x can't be plus or minus 3. Yes? No, okay, did you factor it? Same thing, yeah. All right, that is the domain. Factor the numerator and the denominator. All right, now listen, several of you have forgotten about factoring. I'm doing this easy thing because this is a 1 in front, right? If that were not a 1, I would need to multiply first and last together, and I'd need to group it. I'd need to slash it. Okay, just, yeah.
Yeah, actually, doing without one first.
So y'all want to digress just a second?
That factors to like x plus 2 or x plus 3.
Let's finish this. I agree. Let's finish this problem, and then we'll do it. We'll practice a factoring. Okay. This is x minus 3, x plus 2. And what does the bottom become? Okay, but before you do, tell me what is happening.
Hole in the graph at 3.
There's a hole at 3. Do you all agree?
I agree with that.
Okay. And there's a vertical asymptote just at negative 3. Do you see the difference? Okay.
Because those two cases, I I know that Piecewise are true.
Yeah, I agree. 0 and 9.
Because I set the bottom to 0, and anything that is not a whole becomes a vertical asymptote. Okay? All right. Now, a whole is called what type of discontinuity? No, those are different. It starts with an R, removable, because I can remove it from the equation, right? So my question to you is, if we can remove it from the equation, is there any way that I could plug this hole so that I could include 3 in my domain? How?
Isn't it if you make f of, or you make the,
Try to plug the hole.
I just want f of whatever.
Here's what we're going to do. We're going to plug the hole. We're going to write what we call an extended function. Okay? What we're wanting to do is we're wanting to include 3 in our domain. We want that as part of the domain. Okay? So what we do here is we say, okay, well, if I canceled that out, okay, so now let's call g of x plus 2 over x plus 3.
Me too. I don't like it. I like G of X. I see it on the SAT and they always talk about like relating G of X and F of X.
Okay. Do you agree this is the same thing with the discontinuity removed, with the whole discontinuity removed? So,
basically what we do is we plug in that or
yes.
everywhere X is. So, wait, why would it be G of 3 though?
If you plug 3 into here, once the hole has been right, what do you get?
Well, you would get 5 over 6, aka 5, 6.
Go with there.
AKA.
So now our extended function, we're going to say and we're going to make this continuous on its domain. We're going to say that f of x equals x squared minus x minus 6 over x squared minus 9 when x does not equal 3. But when x does equal 3, it's just going to be 5 over 6. So we are right. This is what we call an extended function.
So basically, let me break it down in steps. First thing that we do is we find what solves the hole. So in this case, 3. And then we plug it in once the hole.
So we find the hole, we plug the hole, and we write the function.
So we write the function. Then we write the function again.
All right. Let's do another. Before we do another, let me see. Maybe this one's a factoring a little bit harder. Oh my gosh. This is. Let's digress for just a minute. I'm going to call this off on a tangent. Okay. 2x squared because we're off on a tangent. This is a side note, sidebar. Yeah, no, that's fine. Just a little math humor for the math nerds in the class. Okay. When I factor this, because the leading coefficient is not 1, okay, I have to multiply the first and the last together, and I get 10x squared. Two things that multiply to 10x squared but add to negative 7x.
-5 and -2.
So now, 2x squared minus 5x minus 2x plus 5. That would have been smarter, but it's okay. Multiply these two together. What multiplies to that but adds to what's in the middle? Yes. And so I wrote negative 7x as negative 5x minus 2x instead of negative 7x. Yes.
Then you just break them off and then factor out both x's.
That's right. Slash it down the middle. What's the GCF here?
X, so you're gonna
What's left?
2x minus 5.
Always keep the middle sign. What's the GCF? 1, it's grouping. I'm factoring out a negative 1, so it's x. Oops, 2x. Sorry. And now this is your GCF.
X minus 1 and 2x minus 5.
Little Algebra 2 refresher there.
Do you remember in Algebra 2 when you threw the kid in here and locked us in with him?
I did. It was in Clyburn's room when he had a sub lesson.
I forgot about that.
We have a time yellow freshman tomorrow.
Let's do one from your homework. Number 30 says, give a formula for the extended function that is continuous at the indicated point. And so I have f of x equals. Do this one at your table without telling everyone the answer and blurting it out, and then we'll do it together. Write an equation for the extended function that is continuous at the indicated point. This is number 30. Exactly what we just did. Okay, so it was 3. It's still going to be a hole to plug. Algebra of it. All right, look. All right, this is telling me at x equals 2, and I know that I'm undefined at x equals 2. Do we agree with that? Okay. This is x minus 2, x plus 2. I am going to assume, because it's asking me to write a function, that the hole is plugged at 2, that this is going to be my hole. If that is my hole, that means that that should be a factor here. You agree? Because if it's a hole, it's going to be an x minus 2 up top that's going to cancel out top and bottom and make a hole. Because it told me plug the hole at x equals 2. Okay? So let's go back to synthetic division. Since this is a cubic, this is the only one that you have one quite like this. All right, look. Man. Synthetic division is easy. Long division? Go ahead.
Wait, I don't really know.
Wait, why? Where did you take that?
I'm down there with you. I don't know how to do that.
All right, so you change the sign of whatever the factor is that you're dividing by. Okay, it has to be x plus a number or x minus a number. No coefficients, no exponents on the x. These are all the coefficients here. Okay, and so you drop it, multiply, and add the column.
Oh, I understand it now.
Multiply and add.
Yeah, but I'm gonna
Multiply and add. Oh my goodness, man. Killing me. Killing me, Smalls. Killing me.
I still don't know what to do.
The same off. Why what? I was just saying that that should be a factor there of this one, because it's telling me there's a hole there, and I'm trying to plug the hole. If it's a hole, then it has to cancel. That's the definition of a hole, is that the factors cancel. So that's how I knew to divide by that, and I knew it would be a factor. Well, do you remember PRZs? Where we started possible rational zeros. Where we looked at possibilities, and then we did this division until we got to one that had a zero remainder.
Like, what if I just like wrote down that number and not the x minus 2 with it? Well, I know, but like, we don't get it. We can get x minus 2 from that. I understand.
The 2 on the outside tells you that x minus 2. It tells you that x minus 2 times this equals what you started with. It's a division problem is all it is. Now plug the hole. Plug the hole at 2. So we're going to call g of x. We're going to remove the discontinuity, call it g of x, and then plug the hole where there was. In fact, in your homework, you don't even have to plug the hole. You can stop there. Plug the hole.
So what you do is you just plug in.
Right. And so you'd write the extended function as what was my initial one? Over when x does not equal 2 and negative 15 over 4 when x equals 2.
I get all this other stuff, but the stuff before that.
Understand what it is we're really doing. Somebody please make this connection for me.
Plugging holes.
Besides plugging holes, what have we done that you just took a quiz on that we're doing without writing it? We're finding the limit. That's exactly what we're doing. We are finding the limit, and you've already done this. We're just saying it a different way. Understand that, okay? You've already algebraically manipulated, canceled out the removable, and then plugged in to find the limit. So really, this is the limit as x approaches what? 2 of what function? The one above it. X to the third minus 4x squared minus 11x plus 30 over x squared minus 4 is going to equal negative 15 over 4.
Oh, that's so cool.
Huh? It's a full circle here, so you, yeah. Which negative 2? Almost. Yep, almost. I know. This is number 48 from your homework. This one you are really going to have to think about, so stay with me.
Is it 31 or 48?
It's not hard. That doesn't mean it's hard. You can't be already lost. You don't know what we're doing. All right. That's an A. What value? This actually was a multiple choice question. It was very, very similar to this 2 years ago. I can't remember. This is a good
It's,
SAT
yeah,
prep
but it's a
question.
lot of AX stuff.
What value would A need to be in order for this function to be continuous?
Oh. Whoa.
Now let's stop for just a minute and let's think about it. No calculator here. No calculator. Y'all are just guessing. Wait just a second. Wait a second. Hold on. There are no asymptotes here, right? There are not going to be any holes. Do you agree?
Wait, why are there no asymptotes?
Because there's no denominator that would equal 0 ever, right? So there's no vertical asymptotes. I know 2x plus 3 is a line. Do you agree?
I would say yes.
No matter what I plug in for A, ax plus 1 is also a line, yes? And where they are cutting at 2, what type of discontinuity am I going to have? A jump discontinuity.
Because the lines like jump each other.
Because that's right. It's a piecewise and they're both linear. So it's going to be a jump discontinuity. So in order to make it a continuous function, the jump has to not jump. Do you agree?
Well, then there's intersection.
Yes. Oh, yes. Yes.
Then it wouldn't pass the vertical line though.
So, it will because one's inclusive and one's exclusive.
Well, then it would still be a jump, right?
It's still a jump.
But I don't know that A value, so I don't know my slope. I know my y-intercept, but I don't know my slope. How am I going to figure out what A needs to be? And let's think about this for just a minute in terms of limits, because you need to be familiar enough with limits to understand. What does the definition of continuous mean in terms of limits? In terms of limits. If I mean,
the limit from the left equals the limit from the right.
huh?
It's 3. It's 3. It's 3.
Limits never go away. Yeah. Okay. Okay. Yes, Ren, it's 3, but I want you to reason through with limits first. I want to think about this with limits. What does the definition of continuity mean in terms of limits? If I want to say that this is continuous at 2, what does, define that in limits? That means that, go ahead, the limit. So, but you're missing a little part there. From the left has to equal the limit as I approach from the right, which also has to equal f of 2. Do you agree? We can figure out f of 2 here. Do you agree with that? I concur. I concur because it says inclusive. So here I know that f of 2 is 2 times 2 plus 3. Just 7. That's f of 2, right? So do you agree that this must equal 7? Okay, what the limit as I approach from the left, we know here is if I plug 2 in. So again, 7, right? So the limit as I approach from the right, which is going to be this equation, must equal this as well.
A is 3 and X is 2.
So 2a plus 1 has to equal 7. So 2a has to equal 6. So a has to equal 3.
I feel like all numbers in calculus are all really tiny.
Hey, how did you pick up like that?
Yes.
Or like a 3?
That was where my discontinuity was happening.
Yeah, either guess 3 or 4.
Okay.
You're just trying to find A.
Yes, you're trying to find, well, you're trying to find A so that it's continuous. At the end of the day, I could put anything in for A and there would be a jump discontinuity there, right? But whenever I define A and I make it so that this is true, I've defined it as a continuous function now. based on the
So
definition.
basically, after we like do everything straight, we need to do the function part first.
Yes.
See whatever.
And if you were in an FRQ situation and you had something like this and part A said what value would be needed to make it a continuous function, you would not get your points if you did not show this. Okay? Because they're testing that you understand the definition of continuity there. They would just ask definition of continuity, or how do you ensure that this is continuous at this point? And you would have to know. Definitions always come back to limit zero. Right. The definition of continuous is the limit definition. Can you sketch a graph where f of 3 exists, but the limit as you approach 3 does not? In other words, this exists.
You want us to do that?
Yeah. Does not. Sketch it.
It would be like a jump. No, it would just be one of the. Oh, and not a jump, but like it would be like here.
So there's multiple different ways you could do this. But yeah, sketch a graph and see. And let's see what kind of graphs we come up with. Dylan, what's your graph look like? Okay. Aaliyah, what's your graph look like? You have a closed point here and an open one here. And then you just went off something like that. Does that, this is just what I asked you. Draw a graph that this is represented. Draw a graph where f of 3 is defined, it exists, but the limit does not exist. Why does the limit not exist there? Different values coming in from the left and from the right. Bless you, man. We're just working through some homework problems now since we had some extra times. I'm assuming that that's okay with you guys.
Do you want to see my graph?
That would be correct. Good job. Did anyone? Well, the first thing that I would do is I would put a point here at f of 3. I would make sure f of 3. It doesn't have to be 3, 3. It could be anywhere as long as x is 3. But I would make sure at 3 I had some point here. And then I would need to draw a function that would not have a limit that exists there. And so by definition of a limit, it has to be the same from the left and the right. So anything here, the limit as I approach either way is not the same. What else could it be? Okay, so yes, as long as it could be kind of like that other one we did, 1, 2, 3, where there was an asymptote bounding this piece of the graph, but then maybe here we had this piece that goes off. So yes, it could be something like that. Good job. Ooh, oscillating would not work here because you couldn't define it at 3 if it was oscillating. Try this one. We're getting a little bit more difficult as we go. We'll try to do 41 through 44 together, so that's not included on here. It was 41.
That was 49. That was the question. Are you?
The one from the right exists. The one. Yeah. Yes, it would actually. That's an arrow. This is approaching 2. Oh yeah, this is an arrow.
I think that's after looking at. I love.
F of -2 exists. I'm just going to put a point. And this point is also the limit as I approach from the right. But the whole limit does not exist.
Like I put a point at -2, and then 2, 4, and do it like that.
Does this work? Does this work?
But that's positive.
Oh, I didn't mean. Wait. I think I wrote it wrong. No wonder y'all are confused. I'm sorry.
Okay. Oh.
It's currently 9:14 in the afternoon.
No, the limit does not because it comes in from both directions.
Would it be wrong if I went to the baby football game instead of her volleyball game? That's what I wanted to do.
Yes, that would be wrong. All right, I'm going to just let you get started.